more like chapter 2 of this, and today we'll be focusing on network cabling. We want to define what is network cables, and we'll look at cable types, we'll look at connectors, cabling tools, and then we'll look at cable configuration. So first off, I'll be defining what a network cable is, and it means that I'll be bringing up a whiteboard. So what exactly is network cable? And if I finish the definition, I'll once again visit that diagram where we see what network cables are. So network cables, simply put, are networking hardware. So by definition, network cables are networking hardware. What do we use these networking hardware to do? We use them to interconnect two or more computing devices together. So network cables are networking hardware used to interconnect two or more computing devices together. Used to interconnect two or more computing devices together. And that's actually the key term there, interconnection. So if I have a couple of PCs and I want them to be connected to the switch in order for them to have internet access, send mail, access the printer and all that, all of these devices will have to be interconnected to a central device known as a switch in order for all those things to happen. So this is the basic definition of what a cable is. They are networking hardware used to interconnect two or more. So it could be two, it could also be more than two computing devices. So it doesn't necessarily have to be computers. So it could also be printers, could also be some smart TVs, etc. These devices are connected together. Why? Because we need them to share information and resources, as we discussed in the last class. Okay, so that's what network cables are. If I take you back to the slide, here you are going to see what network cables actually look like. And this is network cables. They come in different sizes, in different shapes, in different colors. So the ones we are seeing here are basically blue in color, but we also have some that are yellow, some that are black, some that are red, all different colors that these cables come in. So as I mentioned before, they are networking hardware used to interconnect two or more computing devices together. So network cables, as we can see here. So if I pick up my pen once again, let me use black. So here you could see what these cables help us do. So here we'll just keep it. So here you could see that network cables are used to connect multiple computers within a building together to a central device known as a switch. But if you look at this definition, you see here we have a rack. So this is called a rack. And this rack is mounted on a wall, obviously. And on the rack, we could see a couple of switches mounted on the rack. And this company obviously should have more than 20 employees, because the cables we have here, if we count it, should be more than 20. So each of these cables will be taking internet to the different locations that the company staff are seated. And this cable will eventually connect to their systems so that their systems get connected to the network. And so they can make use of network, share files, share information, send email, etc. So that's the whole essence of using cables. So when cables are used to connect these devices to a switch, people will be able to share information. People should be able to share resources, which is the two major advantages of having a computer network in place. So that's what network cables are. And these cables come in different types. We have three major types of network cable. This cat you see here stand for category. We have coaxial cable. And we'll look at the use cases of each of these cable types. And we also have fiber optics cables. So these are major types of network cables. Now, I would like us to look at category cables more in detail. And we'll take a look at which of these network cables are category cables, how do they look, and all that. So let's look at category cable. I'll be omitting some cable types here. In this diagram, you see we have Cat 1 all the way to Cat 7. Just a quick update in this diagram. The category cables we have as of today is from Cat 1 to 8. So Cat 8 is not captured in this picture, but that is the latest technology in network cabling. So here, what I want to focus on is from Cat 5 all the way down, right? So Cat 1 is used in telecommunication. Cat 2 is also used in telecommunication. So think of all those landline, the land phone.
Yes.
So those land phones, they make use of Cat 1 and Cat 2 cables. So this is purely for voice technology. Cat 3 cable is used in data. When we talk about data, we think of connecting a PC to a switch in order for the PC to be able to have access to the internet. So if we have a scenario like that, we call it data. Or if we have a scenario where somebody is making a call, we call it voice traffic. So for data communication, we have Cat 3 all the way to 7, but Cat 3 and Cat 4 are obsolete. So they are no longer used And so what you see in production is from Cat 5 all the way to Cat 8. So we'll have to compare these cable types of category cable. For category 5, which is abbreviated as Cat or Cat 5, here we have the speed of the cable is 100 megabits per second, right? So what it means is that if we have a switch here and I have a PC connecting to this switch, so this is the PC, and this PC is connecting with a Cat 5 cable, and we have another PC or maybe a printer. So we have a printer connected to another port on the switch using the same Cat 5 cable. If the owner of this PC want to send a document to the printer in order to print it, at what speed will the document travel from this PC, follow the cable, get to the switch will forward it to the other port that the printer is connected to, and the document follow that port and get to the printer? At what speed should that document move? It depends on the type of cable we are using. So if you're using Cat 5 cable, the speed will be 100 megabits per second. If you're using Cat 5e, it will be 1000 megabits per second. If you're using Cat 6, it will also be 1000 megabits per second. If you're using Cat 7, it will be 10,000 megabits per second. And if you're using Cat 8, it will be 25,000 megabits per second. So let me quickly go through them again. If we're using Cat 5, the speed will be 100 megabits. If you're using Cat 5e, it will be 1000. Now, what we are seeing here is 1 gigabit per second. It's actually the same thing as 1000. 1000 megabits, that is Mbps, is equal to 1 gigabits. Okay, so if we want to convert this 1 gigabit to 1000 megabits, all we do is do 1 times 1000. And so this one is 10,000 megabits per second, but when converted to gigabits, that is by 1000, that gives us 10 gbps or gigabits per second. And so the major difference between these cable types is the speed at which they transmit signal. That is one. Second, the distance at which the cable can cover. So you see that all of them are mostly the same distance, 100 meters, 100 meters, 100 meters, 100 meters. So it means that if my switch is here and the PC I want to connect to the switch is somewhere here at the edge of this window, we have to get a longer cable to run from this PC to all the way down where the switch is located. Now, if the distance between the switch and the PC goes beyond 100 meters, then the person using this system will not have network, because we have gone beyond what the cable can travel. And that's what we mean by distance. Okay, so when we are designing solutions for companies, we have to have in mind that these cables have limitations in terms of how long they can transmit signal. And so imagine your MD is at the 2nd floor. So if MD is seated, let's say MD is at the 3rd floor, somewhere here, and you mounted your switch at the 4th floor, and you want to run a cable to connect MD's system all the way up to the 4th floor. If it goes beyond 100 meters, MD will not be able to browse, MD cannot access the printer, MD cannot do anything on the network. So it's as simple as that. And that's what we mean by cabling distance. So you see, by default, all of them are on 100. But because they can travel 100 megabits per second, 100 meters in terms of speed, doesn't mean that we should always keep that distance. In the real world, forget about this 100 meters. This is on paper, right? In the real world, don't allow your staff systems to be more than 40 meters away from your switch. And that actually is the general rule of thumb. In the real world, if you go 100 meters, there will be poor signal. So there will be fluctuations. The signal will go up and come down, go up and come down. And so if people are making calls, like using IP phones on the network, the phone, sometimes the call will drop, the call will cut off. So it's all of this coming when we are designing the network from the scratch. So we ensure that we have enough cables, and from design, we don't want to centralize all our switches in the same place. We want to design it in a way that each floor should have their own switch, in order that people on this floor connect to the floor that their own switch is located, right? So if we have, let me bring up a whiteboard once again. So if I have something like this, where this is maybe 4-story building, and here is the 4th floor, and here is the 3rd floor, and here is the 2nd floor, and here is the 1st. And of course, we have the ground floor, right? So we don't want to bring, normally the switches we are talking about, a switch can have 24 ports, right? And those ports are where the systems of our staffs will be connected to. So a switch that has 24 ports means it can take 24 devices of our staffs. That is 24 staffs. And so we need to know how many staffs per floor do this company have. So imagine a company that have 50 staff per floor. That means we'll be looking at getting 3 switches for them, right? On each floor. Because 2 switches of 24 ports will give us 48 ports. And we will have 2 staff left, not having where to connect their own systems, right? So we are going to put 3 switches per floor, assuming that each floor has 50 employees. And why are we putting each switches on each floor? If we come and put all the switches in the same location, we'll have to run a long cable from ground floor to where the switch is located. And we'll run another long cable from first floor all the way to the fourth where the switches are located. But if we decentralize it, where each floor have their own switches, see what we're going to do. The fourth floor will be the switches that will bring in internet. So from this fourth floor, we are going to connect the entire infrastructure we have to an ISP. Who is ISP? Internet service provider. Any company that gives you internet service, you buy data from them and you pay for the data you are using. They are called internet service provider or ISP. Okay, so back over there in Canada, you probably have ISPs like Comcast, Verizon, AT&T, etc. Maybe you have ISPs like that. And so those guys provide you with internet services and you pay them maybe prepaid or postpaid, right? So you pay at the end of the month and all that. Those are ISPs. So from the fourth floor, we are connecting our entire infrastructure to an ISP so that ISP send down internet to us. So that internet is residing in the fourth floor. The switches we have in other floors like third floor, second floor, they don't have internet. That means if we want to bring internet down to third floor, we use a short cable to connect from the switch in the fourth floor to the one on the third floor, right? So internet will drop from the fourth floor to third using shorter cable, right? And all the PCs in the third floor can now connect to switches in their own floor. And then how do we get internet down to second floor? We have to use another short cable to run from the third floor switch to the second floor switch instead of running all the way from fourth floor. And to come down to fourth floor, we put switches here. We're connecting from second floor to first. And from first floor, we are connecting to ground floor. You see, by design, you have eliminated using long cables. And that's all of this coming to design. So if you already know some concepts of what network cables are and what are their strengths, what are their weaknesses, what is the distance they can transmit signal, we'll now be able to come up with a solution that will ensure if you look at all these cables moving from floor to floor, they won't be more than 14 meters. In fact, most cases, 25 meters, 27 meters cable. But we know that on paper, we are told they can go 100, but the higher the distance, the poorer the signal. So you just have to know that.
Okay.
All right. So do you have any question at this point?
No, it's very clear, actually. I like how you explain what it is paper, but reality, it's completely a little bit different, right?
Right. Okay. Just for emphasis sake, we have the cables that are in use as of today is Cat5, Cat meaning category. And we have Cat5e. So Cat5e is totally different from Cat5. And we have Cat6 and we have Cat6a down. You don't need to bother yourself. How do I know which one is Cat5? When you see a network cable, look at the body of the cable. You see it written on the body. So they are written on the body. So you could just look at a cable. You say, oh, this is Cat6. You see Cat6 written on the body of that cable. And we have Cat7 and we have Cat8. Okay. Cat5 is the, in terms of performance, is the poorest of the cables here. This guy has just 100 megabits per second. So the speed, our internet speed, our network, if you want to measure how fast your network is measured in a unit called megabits per second. So this should be the speed. And here, this guy is 1,000 megabits per second, which means that is 900 Mbps faster than Cat5. So you subtract 100 from 1,000. This one is 900 Mbps faster. Cat6 is also 1,000 megabits per second. Cat6a is also 1,000 megabits per second. The difference between Cat6 and Cat6a is that in terms of distance, Cat6a doesn't go up to 100 meters, right? So in terms of distance, this guy goes 100 meters, this guy goes 100 meters, this guy goes 100 meters, but Cat6a travels only for 55 meters, but is also 1,000 megabits per second. Cat7 is 10,000 megabits per second. If we convert it to gigabits, that would be 10 Gbps. It's also 100 meters in terms of distance. This guy is 25G, okay? 25 Gbps. That is in gigabits. But in megabits, that would be, if we multiply this guy, 25, by 1,000, that will give us what? 25,000 Mbps. Okay? So this is either you write it in gigabits by multiplying by 1,000, or you write it in megabits. Okay? So this guy also travels 100 meters. And so these are the different cables we have. On a good day, the cables I can use here will always be Cat6, Cat7, and in a massive data center environment, Cat8. So I don't go for Cat6a, I don't go for, except if I don't have a choice to make. So I'm in a site to set up a network infrastructure, and the client already have purchased all the cables in advance, and what they have is Cat5e. Then I have to make do with what they have. But if I have the opportunity to buy it for them, I'll always go for minimum Cat6, or I have to go higher to Cat7 or Cat8 to get more speed on my network. So that is what I want to point out on those cables. So we want to make progress now and look at other facts about network cables.
I have one question about
all right.
Going back, the cat, you say cat 6A has a 55.
Okay.
Right? Not speed limit, not 100. 55, yeah. Megabyte. So what is it? Why is that the A is like 55? Can you like a little bit explain more? Why is it that?
Okay.
And all the cable distance is 100.
Okay. So if I go much more into details about Cat6A, Cat6A optimized can actually go up to 10,000 megabits per second. That's the max, right? So at this 55 meters distance is already way above 1000 Mbps, right? So
yes.
it can go up to 10 meg, 10,000 megabits per second. But then at that level, at that distance, at that speed, the distance it can travel is only 55 meters. Okay, so that's actually a very good question to ask, because Cat6A on a good day can actually go 1000 meg for 100 meters. Anything outside 1000 meg will drop in terms of distance.
Okay.
If you open a network cable, this is actually a network cable. This cable is the same thing that I showed you here.
Yes.
Right? Okay, so here, when you open up the cable, there are 8 wires inside. Okay, so just as a put here, there are 8 wires, and these wires should be arranged in a way that after arranging it, we have to put it inside this guy. You see this guy here? The name of this guy is RJ45 connector. And so when we have arranged the wires inside the cable, insert it into the connector, it will now look like this. So you can see this one here is already arranged, right? So this connector you are seeing here is what will go into your PC, into your laptop. And the other end of the cable will also have to be arranged to look like this as well, so that other end goes to switch. The way the cable is looking, there's no way to go into your laptop like this. And there's no way it will go into the switch like this. So it has to be arranged and inserted into a connector, and the connector will now make it look like this. And so we'll now insert it into one side into our PC, the other side into the switch. Is it clear?
Yeah, thank you.
So the way this cable is, there are different colors. So each color comes twice. Like, let's take this first one, for instance. You see that we can see white mixed with blue.
Yes.
This very one here is a white and blue color mixed together. And we have solid blue.
Correct.
Here we have white and brown. And we have solid brown. Here we have white mixed with green color on the same wire. And we have another wire twisting to it that is solid green. We have solid orange here. And we have white mixed with orange. Now, why I'm taking time to point out those colors is eventually I will show you how to arrange the cables, and there is a rule that we must follow. The rule says that certain colors must come first, certain colors must be in the middle, certain colors must come last before you begin to insert them into the connector. Okay, so you see, you don't just put anyone you like first. So some colors is mandatory, they come first, some colors will follow it, and some colors will come last. If we fail to follow that standard, the cable might still work when we use it to connect a PC to a switch, but the speed of that cable will no longer be up to what we have discussed so far. The speed will drop massively because we didn't follow the lay down procedure of configuring the cable.
For example, you guys have to put the wire even together. It doesn't come ready for you guys.
Yeah, so what we do first, you can see that the wires are twisted. First thing we do is to untwist it. And as you untwist it, you make them straight, because as they are looking, they are not straight.
Yeah.
So we have to straighten the wire.
Yeah.
And then we now begin to push it into the connector until each of the 8 wires. You can see here on this connector, I said it has 8 pins, right?
Yes.
It means that there is a hole into 8 places for each of the 8 wires to go into its own hole. That hole is what we call pin. Right? So as you are pushing these wires into the connector, there is a hole for each wire to push into and stay there. Okay, so and each hole is meant for each color of the wires, and that's why you can't just mix up the colors. So you must put white blue into a hole meant for white blue, and you must put solid blue into a hole meant for solid blue. the cables, first of all, have to be untwisted and be straightened in a way that each of the wires will be very close to each other, but no wire should be on top of each other. So all of them should be in straight line like this, and then we'll insert them into the RJ45 connector.
So as an IT person, like for you, let's say if you're setting up for the cable, it will come like the way we see the first picture, right? Like, and then it comes like that manufacturing.
Yes.
Like okay,
yes.
That's what I want to know.
Yes.
You don't just get any cable and you're making it, but it comes like that. Then you straighten up. And then you make sure.
Yeah, there are some tools we will use to strip off the back. Actually, the cable, you see this cover here, where I'm highlighting.
Yeah.
It covers everything like this. It covers it to the mouth, right? So we need to use a certain tool to strip off the back cover so that we'll be able to see the wires inside.
Correct.
And we begin to untwist the wires.
Oh, okay. Yeah, good to know. Yeah.
And so the cable come in a pack. It's inside a carton, right? And inside that carton, there is something like a wood, right? There is a wooden object here. Sorry, I want to pick my pen. So here there is a wood, like a circular format, inside the carton, and then they roll the cables around it. Right? So you have to roll it so that all of them, the entire a carton of cable, if you are to unroll all the cables in a carton, the length is 304 meters in one pack. Okay, so if you have so many floors in a building to network, you need to know the positioning of the systems and the length of cables that will get to each system to be able to know how many cartons of cables you have to purchase for the entire building. Are you getting the idea?
Yes, absolutely.
So in a building, in the first floor, we need to map out where our switch will be located in the first floor, and we now need to know where are the staff to be seated, and we need to have a measurement of what it takes this particular staff to get connected to where the switch is in the same floor. And we'll add up all this per floor, and we'll be able to know, oh, maybe we'll be needing 12,000 meters cables to network the entire building. And we already know that one pack will give us 304. And so we can do the math and come up with how many total of cartons we'll be purchasing for that company. There is another connector here, RJ11 connector, that has 4 pins. I don't want to cover it because this is purely used in intercom. All those landlines, that's where we use RJ11 connector. So here I'm focusing more on data network, computer network. That's where we use RJ45. Or RJ11 is purely for telephone lines. So we know that major cables that we'll consider when it comes to category cables are from Cat 5 to 8, though we have Cat 1 to 4. 1 and 2 is for telecommunication. 3 and 4 are obsolete. But from 5 to 8 are for data network or computer network. So let's look at another type of network cable, because up here, we did mention that there are 3 types of cable. What we've been discussing all this while is category cables. Let's look at coaxial cables, and then we'll wrap it up with fiber optics. So coaxial cable. So you can call it coax, as I put it here. So if I pick up my pen, you see here I use coax. You could also refer to it as coaxial. So it's a copper cable. So what is copper cable? Think of the cables that the electricity company used to wire up your entire building so that you have electricity. So that cable is an example of a copper cable. So this coaxial cable is also from copper. So it transmits signals using a method called radio frequency. So it uses radio frequency, or for example, RF for short, to ensure that signals move from point A to point B. And so there are many different types of coaxial cables, which I would like us to look at them in a minute. But coaxial cable also makes use of what is called RG, which is radio guide. And so radio guide is, simply put, the measurement of radio frequency signal that is passing through the coaxial cable. So the way of measuring that radio frequency signal is called radio guide. So that's actually the introduction of coaxial cable. One major important thing here is that it's mostly used in outdoor networking. Cable TV company will have to set up a modem and probably a dish in your building, right?
Yeah.
So the cable, that black cable that connects from the modem, that modem, we call it indoor unit because it stays indoor all the time. So it's indoor unit. The dish you have mounted outside is called outdoor unit because it stays outdoor all the time. But then there is a black cable that connects the indoor unit to the outdoor unit, right?
Yeah.
That cable is called coax or coaxial cable. Okay, so it's mostly used in television broadcasting. So the cable that connects your decoder or modem or indoor unit, whatever name you call it over there, that connects it to the dish outside is an example of a coaxial cable. These coaxial cables, they can travel up to 500 meters, so much longer distance compared to category cables. It means that your dish that is mounted outside, it can be 500 meters away from the indoor units or the modem that is inside. But you know that this indoor unit connects to the outdoor unit, but there are other ports on this indoor unit that will connect to your television. right? So that you can get audio as well as visuals. Okay, so that cable we use in those connections are called coaxial cable. So look at an example of coaxial cable. You see what I was trying to explain before, even in category cables, inside the carton. Inside the carton for the cables, there is this wooden object that is round, and you can see they roll the cable around it.
Yes.
That's how they're able to contain the quantity of the cable inside the carton. You have to roll it, and so both the cable and this wooden object will be inside the carton. When you take one of these coaxial cable that you are seeing here, if you unroll it and bring one out, it looks like this. So you have to cut out the outer covering, which is the black. You see another inner covering. You have to remove this other one. You see another inner covering, which is like silver. You have to remove it before you see the actual cable. This is the actual cable, the core. Okay, so this is the coaxial cable, but all of these things you see are layers that are just there to protect and cover the cable and protect it from dawn. We should be able to withstand harsh weather condition. That's why it has so many layers to protect the cable. Let's look at the different types of coaxial cable. We have RG58 cable, and as I mentioned before, I said the radio frequency signals are measured in what is called radio guides, right? So radio guide, RG, is a measurement of radio frequency signals passing through the coaxial cables. So the coaxial cable types RG58 and RG59, these two types of cables are used in CCTV system. So you probably go to shopping malls, you see cameras everywhere. How CCTV system works is that there is a brain called DVR, right? DVR is digital video recorder. So inside this DVR, there will be something like a memory card or a hard disk, right? So you can insert a memory card, maybe 128 gigabytes or even higher. And there will be a cable that will run to wherever a camera is mounted. So here we'll mount a camera. A cable will come from the camera to the DVR. We'll mount another camera up here. A cable will come from the camera to the DVR. So all the footage that the cameras are capturing as activities are going on in the office, the cameras are busy recording all these activities. Where would they be stored? The cameras will use the cables to forward those activities to the DVR. And inside the DVR is a memory where those videos will be stored so that if anything gets missing tomorrow, we could review the videos, right? And so you can't just mount cameras with cameras not knowing where to send what they are recording. So there is a DVR, digital video recorder, that all the cameras must be connected to using a cable. And the type of cables we can use in that is either RG58 cables or RG59 cables. Another type of coaxial cable is RG6, and this is the one you see at the back of your decoder connecting to your dish outdoor, or what you call modem, or you call it indoor unit. But the point is that indoor unit must connect to a dish outside for your TV to get signal. And so you'll be able to listen to Al Jazeera, watch CNN, etc. And so that cable you see at the back of that decoder or modem that connects to the antenna mounted outside of the building is called RG6 cable. So those are mostly used in television broadcasting. And so we have RG11 cable, which is used in high definition television broadcast. You see, there is analog TV and there is digital TV, or those cable networks. Those are digital. The resolution, the quality of video we see are far superior to that of DVD. So those are high definition. It has its own type of cable that allows for high speed transmission, and that is RG11. So both of these cables are used in TV broadcasting. RG6 and RG11, there is a common name, they call it 4K. If you go to Google and Google 4K audio, 4K video, they will break down what they mean by this. This is high definition, high quality video and audio solutions. And so these are the different types of cables. So just for emphasis purposes, RG58 and 59 is used in CCTV system. These two are used in television broadcasting.
Now we have it. Now in Canada, we have the 8K. You know, we used to have 4K, right? The 8K TV come out now. 8K. You know how you say 4K?
Yeah.
Now we have the TV. Now they have it 8K.
Yeah, they have 8K. Yeah, in developed, highly advanced countries, they have 8K. But in some developing countries, they're still within 4K. Yeah, you're correct. Yeah. So now let's look at the different types of connectors. So the connectors used in coaxial cable is totally different from the connectors used in category cables. So here you can see that the connector we use here in category cables it totally looks different. Here, this is RJ45 connector. Compare it to what we have here. They look different. And so you see, maybe at the back of your TV, you have something like this. At the back of your decoder or your modem that gives your TV visuals. This is the connector that you see that connects your modem that is indoor to the one outdoor, your dish or your antenna. So these connectors come in different sizes, in different shapes. We have BNC connector. What I'm using here in my home for my cable TV is BNC connector. That's what I have at the back of my modem. So it depends really on the connector type that the modem accept. But it could be this, could be this, could also be this. This is a threaded nail connector or TNC connector, and this is a sub-miniature version B or SMB connector. So these are used mostly in telecommunication equipment. Like you have seen something like this, like a radio tower, like a mast, right?
Yes. Yes.
And you see something that looked like so big, like a band mounted on top.
Mm.
Have you seen it?
Yes.
All right. So this is used in telecommunication. Why this mast is because, let's say somewhere I'm here with my phone, and you are here. You want to call me. This is you. You want to call me. This mast will give you telecommunication signal to your phone and get you connected on the network. But then you are calling me, and I'm not here with you, right? So I'm all the way here. So there should also be a mast closer to me, right? But this your call can't just jump through the air and get to the mast closer to me, so that the mast send the signal, send the call down to my phone, and my phone start ringing. So because of distance, there will be other masts in the in between, right? And those masts will also have those things like band. Those actually are transmission antenna. Some of this antenna can travel up to 50 kilometers, right? And so this call that you are making will be forwarded, sent out by this antenna. And there will be another mast. Any antenna you see, there must be another mast facing it, so that another antenna on that mast will receive the signal. And so this one is going to receive the signal and send it out through this one. And this one will send it out. Another mast will receive it. They will be doing it until the call get to me. Right? So all these radio equipment you see, they actually make use of this SMB and TNC connectors. So everywhere is kind of like messed up with diagrams, but I hope you get the idea. That's
you're very clear.
Yeah, so that's where some of these connectors, they are using telecommunication equipment in connecting microwave antennas to the telecom equipment that we have in the shelter. So that is actually different types of connectors that we have out there. The last type of network cable that we're going to look at is fiber optics. This one is a monster type of cable. So fiber optics is a cabling technology used mostly by ISPs. And ISPs are internet service providers. So back here in my own zone, you don't have this kind of ISP over there in Canada, so you have things like Comcast, Verizon, etc. But here we have MTN, we have Glo, a host of them, Airtel, Spectranet, etc. These are the ISPs we have here, or the internet service providers, and these are the guys that mostly use fiber optics cables. They lay it on the ground. Have you seen people running cable on the ground?
Yes.
Yeah. So that cable they are burying, they will put a pipe first, either a green pipe, a yellow pipe. They'll have to get some people to dig it. Sometimes they dig it across the road. Because they pay franchise to government, so government will not disturb them. So they are going to run a cable. So you can actually connect the two offices with a cable using fiber optics. Okay. So fiber optics is that good. It transfers data signal in the form of light and at a very monstrous speed. So some of these fiber cable, they are made of plastic material, while some other fiber cables are made of glass materials. So glass materials, of course, cables made with glass are much more expensive compared to the ones made with plastic. But the point is, we use these cables in a long distance connection. Back here where I am, a company can connect their Lagos office to their Abuja office, which is over 250 kilometers. They can connect the two offices together with a cable. Just have to run it on the ground and get to where you're going to. So that is the type of cable they call fiber optics. It's used mostly in long distance, high speed application. So there are two major types of fiber optics cables. We have single mode fiber. That's what we call here for short, SM. And we also have multi-mode fiber, and that is for short. Multi-mode fiber, I'll be talking about that in the next slide. But for single mode, they travel longer distance. This kind of cable is capable of transmitting data at up to 40 gigabits over hundreds of kilometers. And of course, the higher the distance, the lesser the speed. But these are cables that give you 5G speed. If you want a very high connection, high speed internet access, it has to be provided by a fiber optics cable. So single mode travels quite longer distances, even more than 75 kilometers distance. When we compare that to multi-mode travels a shorter distance. Maximum speed for multi-mode is 2 kilometers. And that makes it ideal for data center networking. So for instance, within the data center, I might have a need to connect a switch to another switch. Why should we connect a switch to another switch? So let's say I have a switch here. I have a couple of staffs connected to the switch, but on this switch, I have a printer. Then I have another switch here. My home system is connected to the second switch, but unfortunately, there's no printer on my own switch. So I have to now access a printer that is on another switch. In that case, the two switches will have to be connected together with a cable, so that when I want to access a printer, my document will have to leave the switch and use the cable to get to the other switch and then be forwarded to the printer. Okay,
Mhm.
so if I want this switch, let's call it switch B, and let's call this one switch A. So if I want this switch B to talk to this switch A at the speed of light, at a very high speed, then I have to use a fiber optics cable instead of using category cables. Okay, so when it comes to using fiber in connecting switches together, we think of using multi-mode because that is one that travels shorter distance. All right, so multi-mode cables are generally cheaper compared to single mode. So they are less expensive to operate, they are less expensive to install and maintain, and they also provide us with high speed and high bandwidth over short distances. Keyword, short distances, maximum of 2 kilometers, while single mode can go much more further than 2 kilometers. So those are the major types of fiber optics cables. Let's look at the connectors we have. I have images for the connector types. You could see that they are totally different from the category cable connectors or Coaxial cables connectors. So here we have LC connector. That's it. This guy here. Look at the name, lucent connector. That's what the LC mean. And here we have SC connector. Look at the shape, and it's called subscriber connector. That is SC. And here we have FC connector, and FC is what? Fail rule connector. And the last one here is ST connector, which stands for what? Straight tip connector. These are not the only types of fiber connectors, but these are the mostly and widely used fiber optics connectors. So those are fiber connectors. And now I want to cap up this class for today with showing you how to configure network cables. How do we make cables? If I go up here where we started, I showed you that for category cables, you have to first of all untwist these cables. And you remember that there are different colors here, right? And after untwisting the cables, you have to arrange them color by color, depending on the standard that is allowed before you begin to insert them into the connector called RJ45 connector. So we have gotten to how to arrange those cables. Okay, so cable configuration here. And when we're talking about cable configuration, we have two standards. We have the, by the way, this TIA stand for Telecommunication Industry Association, telecom, right? So Telecommunication Industry Association or Telecommunication Industry Alliance, and the EIA stand for Electronics Industry Alliance or Electronics Industry Association. So these two bodies set up the 568 standard. And what does the 568 standard say? It guides us on how we should arrange and configure category cables. You notice that in a category cable, there are different colors, right? And out of those colors, we have to arrange them in order. The first color should be the number one cable that you should take into the connector should be cable that is white and green. You know, we have white and green and we have solid green. We have white and orange and we have solid orange. We have white and blue and we have solid blue. We have white and brown and we have solid brown. The number one wire that should go into the connector is the one that has a color what? White and green. The second one should be what? Solid green. The one that has white and orange should be number 3. Solid blue should be number 4. White and blue should be number 5. Solid orange number 6. White and brown number 7. Brown number 8. This is the order. The same thing is applicable here. White orange, orange, white green, blue. White blue should be number 5. Solid green should be number 6. White brown should be number 7. Brown should be number 8. So once again, I'm trying to explain these colors that we have in this cable here. So you could see here we have white and blue, and we have solid blue. Here we have solid green, and we have white and green. Here we have solid orange, and we have white and orange. Here we have solid brown, and white and brown. And so here is telling us which of the colors should come first, and which of the colors should come second, and which of the colors should come third, and fourth, and fifth, until we get to the 8th cable or wire. Are you getting the idea?
Yes.
All right. So now, in making this cable, you have to select which standard you want to use. We have T568A and T568B. 568 is the standard, right? And the T meaning Telecommunication Industry Alliance. That is T. So now, the cable you are making and how you should arrange them depends on what you are connecting. What device do you have to connect? Let me give you an instance. 2 types of cables can be configured. What are those types of cable? One is called straight through cable, and the other one is called crossover cable. So you can see crossover cable here. Yes. And here we'll see straight through cable. Now let's look at the diagram here. When you want to connect a PC to a switch, or you want to connect a switch to a router, what type of cable should we configure? Straight through cable. This cable is used to connect dissimilar devices. What do we mean by dissimilar devices? Devices that are not from the same device family. For instance, switch and PC, do they look alike? No, because they are not from the same device family, right? You see a switch here, it totally looks different from a PC.
Correct.
Right. So if I'm connecting my staff PCs to the switch, the type of cable I should be configuring is called straight through cable. How do we make a straight through cable? Let's see how we make it. This is my cable. You see my marker?
Yeah.
So this is a cable. We know that we have to arrange one side of the cable and put RJ45 connector there, right? And we arrange another side of the cable and put another RJ45 connector, right?
Correct. Okay.
So now if I'm using T568 standard, which one is T568 standard? The one on the left, right? It means that all the wires I have here, the first wire that will get into the connector will be a wire that has two colors, white and green. Second should be what? Solid green. Third should be white and orange. Fourth should be blue. Fifth should be white and blue. Sixth should be orange. Seventh should be white and brown. And eighth should be brown. If I use that standard to arrange my wires here into the connector, and I'll repeat exactly the same thing this side.
Oh, okay.
Meaning that both sides will be arranged using the same formula or the same standard. That gives us a straight through cable.
Okay.
Okay. So if a cable is configured where all the wires that will go into the connector this side are using the same formula with the other side, so we say both ends of the cables are configured identically, then that is a straight through cable. It could also be that we want to use this other standard, right? So it means that we are using T568B. It means that the first wire will be what? White mixed with orange. The second should be what? Orange. Third should be white and green. Fourth should be blue. You get the idea? So if we use this formula this side, the point is we should maintain the same thing the other side. It should never change. So if you're using B here, sorry, I was supposed to put B here.
Have to be B, right? Okay, yeah.
So if I'm using B here, here should also be B. But if I decide to use A, the other side should also be A. So if we use that type of configuration, then we can only use that cable to connect PCs to a switch, as we have here, which is what we are seeing here. Or we use it to connect a switch to a router, which is this switch here connecting to a router. And that's where we make this kind of cable. You understood that? All right.
Yeah, very clear. Like you cannot, basically what he's saying is, you cannot, if I understood correctly, it's like you cannot use one side A, like how you explained it was A and B, right? Like, so you cannot make it one side A and the second B. You have to be both same way.
Both have to be same.
Yeah, have to be A, the other side.
That is the standard. If you make one side to be A and the other side to be B, you are now making a totally different type of cable.
Correct.
So look at this diagram here. And so these are the wires we are making. So one cable or one wire has two colors on it, which is white and green, right?
Yes.
Another has solid green. This is white and orange. While we have blue, we have white and blue. We have solid orange, white and brown and brown. And that's exactly what we have here. White, green, green. That is it here. White, green, green. And so you see, we repeat the same thing both sides. And so this is the cable. So we have to untwist everything here and arrange it in this order. White, green comes first, followed by what? Solid green. And we'll repeat. So both sides are identical. So here we are using T568A. And here we're also using T568A. Identical both sides of the cable.
Correct.
Now, if we want to make another cable called crossover cable, this one is used to connect similar devices, devices that are from the same device family. For instance, I want to connect a switch to a switch. I want to connect a PC to a PC. So you can see PC1 is connecting to PC2. The type of cable we should use is called crossover cable. Or switch 1 is connecting to switch 2. Okay, so what makes a crossover cable? This is the cable. We have to arrange the colors here and put it inside the connector. We also have to arrange the colors here and put it inside the connector. If we're using T568A here should be B. Right? So here will be T568B. So when one side is A and the other side is B, the cable we made is called crossover, not straight through. In straight through, both sides must be the same. In crossover, if we are using T568A here, so you could see here, we started with white, orange, white, green, green, right?
I think, can I say something about the color?
Okay, here.
Yeah, no, the other color, the page 28.
Okay.
Yeah. You know what I noticed? People can make it a little bit mistake when it comes to the one thing, because you see it's white and green, orange, blue and orange. You have solid blue and then white and blue, then orange, right? And but the other color, they're all behind each other. Only 3 and 7 and 6, they not, because there is the orange, there is a gap between.
Yeah, if you notice the cable number 4 and 5, they are the same both sides. Blue and white blue, right?
Yes.
Those ones carry power supply. They carry electricity. They carry power.
Oh, okay.
They don't carry network signals.
That's
okay.
right.
So
so it doesn't matter. Technically, they're still the same than orange and solid orange. Okay, got it.
Now you see the first wire here is white green, while this first one here is white orange. And here white green green. This is white orange orange.
Yeah.
Okay, so why this is white, orange, blue, here is white, green, blue.
Ah.
Are you seeing it?
Yes, yes.
And
Now I
here we
see.
have white, blue, orange. Here we have white, blue, green.
Yeah.
And so the last two is always the same: white, brown, brown, white, brown, brown.
Yeah.
Okay, so number 4, number 5, number 4, number 5. They are the same thing, right? Both sides.
Yes.
Number 7, number 8, number 7, number 8. Those 4 wires carry electrical signal.
Oh,
So
okay.
you know that these category cables can be used to connect CCTV cameras, right? And those
Yes.
are IP cameras. So where the cameras are mounted, what gives them power so that they power on? This same cable can supply them both signal and power.
Mm.
So the cable can give the camera internet so that the owner of the shopping mall could be viewing the mall in his home.
Yeah.
But apart from supplying internet to the camera, it will also supply it electrical power to power it on. So we don't need to get an electrician to come here and put a socket for the camera to connect to. So these network cables can carry both network signals and power. And that's where we have those ones you see that are the same both sides, they carry power.
Oh, thank you.
Not
I'm
signal.
glad that I asked because I was like, why is it like that? Like the cable. Now I understand. Thank you so much.
All right. All right. So just note that crossover cables, they connect similar devices, devices that are the same. You notice if I needed to copy a file from this PC to this PC, I will need a flash drive or I will need external hard drive. But if there is no external hard drive available, there is no flash available, how do I copy that data or that file from here to here? I can use networking. I will just get a crossover cable, connect this system to this system, configure them, and they'll be able to share files. Even where external hard drive and flash is not available, we'll still be able to copy something here. The thing will pass through the cable and get here. And so we'll still share without having flash. And so if you have a scenario like that where you want to network two systems in order to move information from one system to the other, the type of cable that can be used in that instance is crossover cable. Because you are connecting similar devices, PC to PC, laptop to laptop, they are similar. Okay, you're also connecting switch to switch, they are similar. They are from the same device family, so we still use crossover cable. I hope you get the idea.
Absolutely, yes.
So that's actually it on network cabling. So I will have to make a separate video where I'm actually doing the cable configuration, doing the arrangement of these wires, and cutting off the wires, inserting it to the connector, and send you that video so that you can actually be able to do it yourself. So all that is required for you to do this is buy a cable. So you can get a cable like 5-meter cable, and not only cable. So you need a cable, right? So one, you need to get a cable. 5-meter will be enough. You need to get cable crimper. That's what will help you to, when you insert the cables inside that connector, if you pull the cable, they will come out from the connector. So how do we get the cable to stick there and never come out again? No matter how much force we apply to pull it out, we need a tool called crimper. That's what we use to stick the cables into the connectors permanently, and they can never come out again. And then when we have already stuck the cables into the connectors, there's also another tool called cable tester. So we use it to test the cable to see if it's working if it's functioning well, if there are some defects on the cable. So we'll have a cable tester. All of this, cable crimper, cable tester, I think all of them should be under $12 or $10 to $12 to get all of them. So they are not expensive. But I'll do a separate video that I'll be crimping the cables, and you see actually how to do it. So you should be able to do it yourself when you see that video. But this is where we'll be dropping the anchor today. So today we'll focus mostly on network cables.